React Native developers. This is the Liquid Swipe slider, an iconic user experience that we are going to build together. So let's get to work. Guys, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this video, we're going to look at the Liquid Swipe example, a delightful user experience that was originally designed by the Kuberto agency. We've already made a video on this topic a while back, and at the time, this was just a proof of concept. But in this video, we're going to build a fully fledged slider using this technique, and you're not going to believe how easily such a user experience can be implemented in React Native. So how would we do this in React Native? Well, this is a two-part problem. First, we are going to need to implement the masking of the slides that are on top of each other, and then we're going to build the wave animation. So first, let's talk about the mask. We have a slide component that represents the content of a page. There's a previous slide on the left, the current slide is in the middle, and the next slide is on the right. We could have the slides translate over each other, but that would be no fun. Instead, we're going to use a mask. The way it works is the following. We underlay a black shape under the content. Wherever there is a black pixel under the slide, it will be visible. We overlay the left and right side on top of the current slide. Once we've implemented the slider, we can build the wave animation. We start by drawing a rectangle, and we add an imaginary circle. This imaginary circle is going to drive the shape of the wave and its animation. We can draw 2 points at -2 times the radius on the y-axis, and from there, we draw a new point. We move to the right by the radius divided by 2 and down by radius. Same for the next point. And for the next point, we move to the left by radius divided by 2. And same for the last point. Now let's draw a line across those points. Doesn't look very sexy, but we can smooth out the points. To transform these lines into nice curves, there are many algorithms available. We ship some of them in Redash, but let me show you a very simple way to do it. We transform the lines into curves, and we can play with the distance of the control points in correlation to the radius. And the value that works great is 0.55228474. Well, that's no coincidence. This is a constant used to approximate a circle with Bezier curves. I will link to a great article on this topic in the video description. Now let's animate the wave, and let's remember that this wave that we've drawn so far was entirely driven by this imaginary circle. And now we can animate the radius of the circle depending on how far it is from the edge of the wave. But what do you guys think? Can it be done in React Native? Let's have a look. Before we get started, one thing, if you're interested to learn the fundamentals of gestures and animations in React Native, I hope that you will check out my online course at startreactnative.dev. In the course, we cover all the fundamentals that we will be using in this video. Bezier curve, SVG animations, gesture handling. So if you're interested to learn the fundamentals, I hope that you will check it out at startreactnative.dev. We are into VS Code here, and I have a boilerplate project, which you can download from the video description in case you want to code along with me. I have a list of slides with some informations, and I have the slider component. I have the index as a state to know where we are in the current index. And I have the slide, the current slide as children, previous slide, next slide, if it exists. At 0, there is no previous slide. And on the last slide, there is no next slide. And I give it the index and the setIndex function to know when the index has changed. And if we go in the slider component, we simply display the current slide and the left and the right side left slide on top of it. And we have the wave component, which is completely empty now. And I think we're going to do this in 3 steps. First, we're going to use the mask to display the previous and next slide. Then we're going to add the gesture so we can move the slides around. And finally, we're going to build the nice wave animation using the exact same techniques that we just explained before. So let's build a simple mask for these views. And we're going to use the mask element from React Native. So masked view, children is a child. We're going to also use absolute fill. And we have the mask element attribute, which is the wave we're going to animate. And here we will do the wave later. Let's do it step by step. So I'm simply going to draw a rectangle in SVG. So the mask element, we're going to write an SVG component. Again, here using absolute fill. And so we're going to have an animated path. So we're going to pass some animated props. And we know that the fill is black. So whatever is black on the mask element is going to be visible from the children. So I'm going to do fill black. So now we need to create the animated props. So use animated props. And so we're going to return a simple path for now, I think. So we're going to create some SVG path commands. So I'm just going to return d equals, we're going to join them with a space. So the path commands, so we're going to move at the top left corner, so move at 0, 0. And then we're going to draw, so we're going to start with really the path is simply a rectangle that takes the whole space. So I'm going to draw a vertical line, an horizontal line, sorry, to the width of the Canva. And then a vertical line to the height. So you see you have the H command, V command. The fact that it's uppercase means that we are using the absolute values. If it would be lowercase, it would be relative values. So the height. So we draw down and then we need to go back to 0. So we can do horizontal line to 0 and we can close the shape. Okay, and let me check. So I think here we don't see anything because they are overlaid on top of each other. Maybe if I do width divided by 2, yeah, you see. Perfect. So we have our base mask element. Now let's animate the slides. So we're gonna go to the slider and wrap everything into a pan gesture handler. And we know that the first and unique child of a pan gesture handler is an animated view. So we're gonna use it here. And we need to create the on gesture event. Animated from React Native, no, not vanilla animated, but from React Native reanimated. Okay. Pan gesture handler. And let's create the on gesture event. So use animated gesture handler. And so let's create 3 animation values. First, we're going to create an animation value called active side. So when we start swiping, did we activate the left slide or the right slide? Or maybe if we swiped in the middle, we didn't activate anything. And then we're going to create X and Y value for the left side and X and Y value for the right side. So let's create active side. So use shared value, and the default side is none. And then we're going to create, we need an x and y value for left and right. So I'm going to do left is use vector, which is a redash function that simply creates two animation values, one for x, one for y. So I can import it here. This one as well, probably this one too. So I do left and right. Now, when the gesture starts, we want to check which side we activate. So we're going to look at the x value. And if x is less than the margin width, which is this small margin on the left and right side, we know that we activated, so the active side is left. And for the right side, it's if x is greater than the width minus the margin. So width minus the margin width. So here we will be on the right side. So active dot value equals left, and if not, it equals right. And I guess here for good measure, we can write, if not, it's none. And I think one thing we can do maybe is pass the position here to the wave and use it already in the mask. So here position equals left, and position here equals right. And also, if the gesture is active, so on active, we're simply going to assign x and y to the left or right side, depending on which side is active. So get the xy value. Oops. And so if active side equals left, so x left dot x dot value equals x, left dot y dot value equals y, and if it's the right side, left dot x dot value equals, so we're on the other side, so with minus x, and for y, oops, it's right here, and for right, y doesn't change anything. So that looks good. Let's add the position property. So we know it's a vector of shared values. So of vector of animated shared value. Okay. So we have it here. And maybe here I can do position.x.value. And one thing we can add here is that when we initialize the slide, so use effect. So here we want a default value, which would be the margin width, or I think the margin width. And we want it to animate nicely when it appears. So that's why here we set it at 0. And then we use effect to animate it from 0 to margin width. Let's try. Let's see how it looks. So when we initialize, oops, we can do left.x dot value with spring to margin width, and same for the right side. So here we see the left side. Okay. So the first thing, we only see the left side, of course, because they are overlaid here on top of each other. So if it's if the side is right, I want to revert it on the y-axis. So I'm going to add a style here, a transform, and with a rotate Y. And if side equals side right, I'm going to rotate by 180 degrees. If not, 0 degrees. Okay, so now I see it on the right side and it moves nicely. Let me also update the current index so we can see both. Because here, index is at 0, we only see the right side. But if I update the index to 1, yeah, you see, you have the left side and the right side. So one thing we can do already is that you see here, the left side, because they are children, it's always so if we go here, the right side will always be on top. So if the left side is active, it should be on top of the left side, of the right side, which is what you're seeing here. So we're going to create an animation value called Z-index. And we're going to add a style to the left wave here, so it can go on top of the right wave if it's active. So I move this to an animated style. So I can call it left style. So use animated style. With a Z-index. No, so I don't need to create, what am I doing? I don't need to create a Z-index value. The Z-index, if active side dot value equals left, then it's 100. If not, it is 0. Let's have a look. So you see, up, and see now the left side can go on top and the right side can go on top of the left side. Perfect. So now it's pretty clear that I can add the dependencies here. The next step is to transition when the gesture ends now. So on end, and then once we've done this, we will do the nice wave animation. So on end, we're going to look at X, and I'm going to need the velocity X and velocity Y for the springs animation. So velocity X, velocity Y. So here, actually, you will see that the slider component, the logic is going to be super simple, but every time we do something for the left side, we need to do it for the right side. And maybe there is a way to factor this nicely, but actually the logic is very simple. The code looks a bit heavy, but if you look at the code, it's always because we do things twice, one for the left side, one for the right side. But if not, the logic is super. If you look only at one side, the logic is super simple. So if the value is left, and we're going to need to do something if the value is right. So we need to snap somewhere, right? So what are the snap points on the left side? On the left side, it's going to be margin width here, and or the width. So left or right side. And the destination. So redash as a function, we're given a position, a velocity, and an array of points. It's going to tell you where to snap. So we're going to use, it's a snap point function. So we're going to use this function. So we give it X, velocity X, and the snap points. On the right side, So if it finishes, it's 0. If not, it's with minus margin with. So now we can spring to the destination on both sides. So I can do here left.x.value, oops, equals with spring to the destination. And we're going to use the velocity. So velocity equals velocity x. And same for the right side. Here we know that, so since we take x, we need to do with minus x from the right side. And shall we just try? So here, yeah, it seems to work nicely. Perfect. And now what we need to do is that when we snap to the one of the points where we need to update the index, we will do it. So we have a callback here when the animation is finished. So we need to change the index here on the left side if the destination is with. So if destination is with, we need to update the index. So run, so here we are on the animation thread. So we need to call back to the JavaScript thread and use apply set index. And since we're on the left side, we're going to do index minus 1. So these are the arguments, the argument we pass to set index. So we are calling back to the JavaScript thread. And on the right side, it's if it's 0. So this destination. So destination 0, and we do plus 1. Yes, perfect. And you see it's a bit slow. So this I really like. It's a bit slow to finish. So here, because it's nicely bouncy, it's great, we love it. But if we go, it's like the Tinder example. If we swipe to the left or to the right, we are bouncing outside the screen. And you see there is some delay before the right side appears. And so like we did in the Tinder example, if we are going to switch the page, we want the Spring configuration to finish super quickly because it's going to bounce, but we're not going to see it. We want it to be super bouncy only if it's visible. Like for the Tinder, we want it to be bouncy only when the card goes back to the stack. If we swipe left or right, we just want to apply the side effect as quick as possible. And so this is exactly what we're going to do here, and it works super well. It's kind of a cool technique. So here, so we need to see if we transition or not. So I'm going to create one animation value because we're going to need it. So here for the Spring config, we're going to need it in order to do the wave animation. So I'm going to put it into an animation value. So I'm going to create is transitioning left. The default value is false, and is transitioning right. So here is transitioning left is true if destination is with. So far, so good. Up. And we're going to update the config accordingly, but let me do the right side before. So is transitioning right.value. And now we can update the configuration. So if we are not transitioning, we keep the default Spring config. It looks good. We could make it even more bouncy if we want. If we are transitioning, we want to have no overshoot clamping, meaning the value cannot go above the destination value. And we want the Spring to finish quickly. And there are two values we can, so rest displacement and rest speed displacement. So it's a threshold. When we reach this threshold, we can consider the Spring to be over. And so if we are transitioning, we want these values to be very high. So it finishes the Spring very fast. So overshoot clamping if we are transitioning to the left side, we want to clamp the overshoot. So it's true, or if not, it's false. Then we have rest speed threshold. So at which velocity we consider the spring to be finished. If it's transitioning to the left at a very high speed, let's put 100. If not, very small speed. We want to bounce. So 0, 0, 1, we can just play with it. And then we have rest displacement threshold, which is the same for the position. And yeah, let's just use the same values. And let's do the same for the right side. So you see, every time we write something for the left, we need to do it for the right. But the code, if you look only at one side, the code is actually pretty, I would say, fairly lean and simple. So here, but it's transitioning right. Let's have a look. And you see here, it appears almost instant. It's instantaneous. So fast, well, perfect. But if I move back, you see it's nice bounciness. Perfect. So now let's animate the wave, right? So here it's a straight line. That's no fun. Let's animate a fun wave. So here we go back to our simple rectangle, and we're gonna animate it into something fancy. So we know, based on the description earlier in the video, that we need to draw 5 points based on a radius of an imaginary rectangle, smooth the points, so we have nice curves in between these points, and then, depending on the X and Y position of the finger, animate the radius, the imaginary radius, which drives the whole animation. And so what is this radius? I think we can take, here we have the mean ledge and the margin width. So the margin width is the part which activates the gesture, but then we have a mean margin on the left side. So I think we're going to do margin width. So the part that activates the gesture minus the mean ledge. So this is our radius. And I think that on the X, so I'm going to create step X and step Y. So we're going to move left and right by some amount, and we're going to move down on the Y-axis by some amount. And so on the X-axis, this amount, I think, is radius divided by 2. And on the Y-axis, it's going to be radius. And so we can define our 5 points based on this. So P1, so we're going to start from the center. So P1 is actually the top point, but so I have a function here. Vect2 is simply creates a X and Y vector. So the center is at, here it's going to be position.x.value. And I guess here we could take position.y.value also, but here the default y value is 0. We want it to be in the middle, so I'm going to do height divided by 2. Okay. Now, so the x position is good. On the y, so since on the y value, we need to go up, and we need to go up by 2 times step x, step y, right? Because P3, so this is the y position is going to be the y position of P3. So we have P2, so it's going to be minus step y, and then we have P1, so 2 times minus step y. And now P2, P3, P4, P5 are inferred from P1. So everything is, so we define the radius, and everything is constructed around this radius value. So this is the radius this is the center of this imaginary circle, and the whole wave design and animation is going to be based on this imaginary circle. So P2 is P1x. So on the x-axis, we're going to move up by step x. We're going to move to the right by step x. And for y, we're going to move down by step y. I think it's the same for P3, but based on P2, of course. And then we have P4, where we move down by step, so P4, sorry, where we moved on by step y, but now we go back. So we've reached the apex, and we're going to move back to the left side, so P4, and same for P5, but here with P4. And let's draw these points. So here we're going to draw a line to P1x, and then a vertical line to P1y, and now we can draw our points. So I can do it quickly. Line to P2x, P2y. So here, P3, P4, P5. Doesn't look good. No, I think actually it looks good. We just need to draw then the line, the vertical line to the height. That actually doesn't look too bad. I'm just wondering here if we should use mean ledged instead. Yes. Okay. Looks pretty good. And now we need to smooth out the... So you see we can even move it up and down. But one thing I think is that also we need to spring back the Y position. So that's something we didn't do. So here I need to do right.y.value. We simply spring back to 0, to height divided by 2. And we can use the velocity. And same for the left side. So let's smooth out the lines. So these lines are going to become curves, and we're going to use some control points. And so right now, if we want the curves to look exactly like the line, the first control point is going to be equal to the source, and the second control point is going to be equal to the destination. So let's write this quickly. So we have for point 1, control point 1. Sorry, so C11. So here it means the first one means for the point 1, and the second one means control point 1. And so again, here I'm going to use P1x, P1y. And for the second control point, we're going to do P2x, P2y. Now let's do it for point 2. So it's going to be P2, P3. Bear with me a second while we do this. So third point. So it's going to be P3, P4. And the fourth. So here actually it's the second one. Maybe it's clearer if I do 2, 3, 4, 5. And it's going to be P4, P5. And now if I use these as curves, the lines are going to look identical, but obviously we're going to update these values. Here I have a helper function to write the C command based on some vectors. So let me do this quickly. So we have a curve, so C11, C21, C22, and P2. So here P3. And P5. So it should look identical, and it does. Let me see. I think here again I want to update, not use margin width but min ledge, and probably same here on the right side. Perfect. Now let's move out the curve. All right, so I think that looks good. So now let's do the smoothing. So we have the C constant here that I will link to the article that explains where this value comes from, and we can use it here. So I'm gonna do actually, let me just see, and I'm just simply gonna multiply by R. So this is assuming a radius of 1. And we're going to apply this value to the control point. So here I think, so for the first control point, we're going to add, so we're going to go down to C for the first point. And here we're going to go down by C, go up by C, and I think here probably go up by C. Yeah, looks good, doesn't it? Yeah, perfect. And so now we're going to animate the radius of the circle depending on the Y position. And I think here we can do, so the radius can be, we're going to clamp, I think, the value. This is a minimum value, but I think we're going to take position.x.value as the radius. And the maximum value, let's take width divided by 2. Clamp. And it's position. So let's have a look. Looks good. And maybe to make it look a bit organic, here the R value is clamped, but for the X, so I think it's good for the Y, the X axis, but for the Y axis, we can use the unclamped value. But it still needs to have the max, so the mean, so this value has mean, so I'm gonna do here math max of position.x.value and still use this one. That looks good. And now if we are, maybe also the, no, I think that looks good. Should we make it even smaller? Divided by 3 maybe. And yeah, I think, yeah, that looks much better actually. And we can definitely play with these values. But now let's transition when we release the gesture. And maybe you see 3 is too harsh. So maybe it's 2.2, I don't know. 2.5, sorry. Let's deal now with when we release a gesture. So we have these transition left, transition right, so which we're going to pass as property is transitioning. So here it's is transitioning left and is transitioning right. If we are transitioning, we want everything to go back into a line. So basically what we want is a step X to be equals to 0. So everything is going to be on the transition to the same line, and we want to transition to it. So we want a spring animation, which means that I'm going to need to extract, because you see step X depends on the radius. So we're going to transition from this value to 0, which means that I need to extract this into a use-derived value, because we're going to use with a spring. And since R is also used here, I'm going to extract R as well. I mean, maybe here it's actually faster to duplicate the values. Yeah, so let me maybe just do step X, use derived value. And so we return with spring. If we are transitioning, we spring to 0. If not, we spring to R divided by 2. And here, either I could extract R into a use derived value or copy paste it here. Paste the this one, I guess, is less clean because we duplicated an expression, but might be actually slightly faster. So now step X is an animation value on the, so this becomes dot value. So let's have a look. So here I'm moving around the wave, and it transitions nicely to a straight line when I'm transitioning. And because we have the nice spring config, the change between slides is actually super fast. Isn't that cool? I think the width divided by 3 is a bit too harsh. So you see in some position, I feel like the apex is too big, but we can tweak the values nicely. Isn't that fun? Guys, I hope you enjoyed this example, and I hope that you've been surprised on how easily such a user experience can be implemented. The masking animation is a bit slow on Android because it's all done on the CPU. So instead of being hardware accelerated, so I might update the example to use an SVG mask instead of a masked view from React Native, or I might not use a mask at all for Android. In fact, the Kuberto agency we implemented the example also on Android and iOS didn't implement the masking for Android. Here things are a bit more complicated if you want to use hardware acceleration. But then the wave animation, which was completely driven from an imaginary circle, and we animate the radius of this imaginary circle, was a really nice driver to easily implement a seemingly complex shape animation, but that is in fact actually fairly easy to do. So I hope you enjoyed it. Let me know what you think in the comments below. I am looking forward to talk to you soon, and until next time, happy hacking.